Okay, so what was the idea? So if we start with a square whose aspect ratio is √2. So this is √2 and this is 1. All right, what's the first thing we do?
So we chop the square, so we cut the square of 1 off of it.
Okay. So this becomes 1, and this becomes √2 minus 1.
Yep.
All right.
And then
we cut the √2 minus 1 square off.
Okay. Now √2 is approximately 1.414. So this is about 0.4, and this length up and down here is 1. So how many of these √2 minus 1 squares are we going to have?
So two can fit.
2 can fit.
We only need 1 for the proof.
Ah, we only need 1 for the proof, you're saying. Okay.
So then he says that here, this remaining rectangle is going to have the same aspect ratio as our starting rectangle.
Okay. All right, and then why? Let's just say that's true. That this rectangle here, when we take 1 square away here, that this has the same aspect ratio. So this is going to be the square root side √2 minus 1, and then 1 minus √2 minus 1. So I guess 2 minus √2.
So then
√2 minus 1. So if this has the same aspect ratio as the original rectangle, why does our rectangle never come to an end?
Because then you can keep doing this for smaller rectangles. So this would actually be the big rectangle in another case.
Because you know you can take, out of a big rectangle, you know you can take this square and this square out of it.
All right.
So then this rectangle is now your rectangle, so you know you can take 2 squares out of it. And you've got a new rectangle that you know you can take 2 squares out of.
Okay.
And then it keeps going down and down forever.
And how does this prove that √2 is irrational?
Well, if √2 weren't irrational, if it were a ratio of 2 integers, then every single one of these √2 rectangles would have to be a ratio. Actually, every one of these squares even would have to be a 2 integer side lengths.
Yeah. But
And since there is the smallest positive integer, but we have infinitely many of these rectangles, that can never happen.
because then you'll just run out of integers if you do this infinitely long.
Okay, so if √2 to 1 was a rational number, what we could do, let's say if it was a over b equals √2, we could multiply everything by b, and then the long side would be length a, and the short side would be length b. Right?
Yep.
Yeah, okay. So now this rectangle here would become a b by b rectangle, and this rectangle here would be a minus b and a minus b.
An integer minus integer is always an integer.
And then this rectangle here, well, let's see, it's b minus a minus b. So that's going to be 2b. Okay. B minus a minus b.
So that would be 2b minus a.
That's right. 2b minus a. But we said that this is also a √2 rectangle. So we have a minus b over 2b minus a equals a over b. A minus b over 2b minus a. We know this equals
A over b.
a over b. Which, by the way, we already said was equal to √2. Okay?
Yep.
Alright, so what can I do here?
Well,
So you know this, all of these numbers have to be integers.
Yeah?
I think he used a
What?
difference of squares trick. So did you multiply by 2b plus a here?
Well, so what we want to do is we want to take advantage of this. So we're going to divide everything by b. So we get a over b minus 1 on the top.
Yep.
And 2 minus a over b.
But we know a over b is root 2, so we can replace the a over b's.
So root 2 minus 1 over
2 minus root 2.
Mhm.
And does this, I made a mistake, I flipped it, this a minus b was the short side,
Yeah.
right? 2b minus a. 2b minus a was the long side, so we have 2b minus a over a minus b. So this becomes 2 minus root 2 over
Root 2 minus 1.
root 2 minus 1. And the question is, does this equal root 2?
So we can multiply everything by root 2 plus 1 over root 2 plus 1.
Okay.
And then it looks like, yeah, it will.
Okay, so if I multiply by root 2 plus 1, like he did, on the bottom I get a difference of squares. So I square this, root 2 squared, which is 2, minus 1. So on the bottom I get 1. And on the top, do you know how to multiply this out? 2 minus root 2 times root 2 plus 1?
So that would be 2 root 2 plus 2.
2 root 2
plus 2
plus 2 plus 2.
minus 2 from that.
So minus root 2
Minus
times root 2 minus root 2
Minus 2 and then minus 2.
minus root 2.
So then that just becomes root 2.
Root 2. Okay.
Yep.
So we can use the fact that the root 2 rectangle spiral repeats, and this shows that we can't ever have a ratio of 2 integers. It shows it in 2 different ways. One, if it was a ratio of integers, it couldn't repeat. It would stop eventually. But second of all, the repetition shows if I'm going to have this relationship, it has to be an irrational number. So I'm actually not explaining that well, but fortunately he explains it correctly in the movie. Right? Do you guys like this movie?
Yeah.
Okay. It's really neat. All right. Hey, good work, guys.